There are moments in the history of our species when the veil of the unknown is drawn back so imperceptibly that for a heartbeat, the universe seems to breathe in concert with the fragile hopes of humankind. On an evening that, at first glance, appeared no different from any other, a confluence of quiet diligence and cosmic coincidence would alter the trajectory of planetary science forever. This is the tale of how a new world, unseen, unimagined, was wrestled from the darkness, its existence revealed not by accident, but through the persistent, searching intellect of those who dared to listen for whispers, where others heard only silence. The air was heavy with anticipation in the dome of the Keck Observatory, atop Mauna, its twin telescopes poised like sentinels under the ink-black Hawaiian sky. The faint hum of cooling fans and the sharp click of relay switches formed a quiet chorus in the control room, where Dr. Nia Sangare, an astrophysicist whose curiosity had long since become legend among her colleagues, peered at the fluctuating readouts. For months, she and her team had been monitoring the subtle dance of a distant star, catalogued as HD 21749, searching for the telltale wobble that hinted at planetary companionship. The process was methodical, painstaking, a marathon of patience and precision. Yet that night, as the data streamed in, something shifted. A deviation, minuscule but persistent, and repeated at intervals too regular to be dismissed as mere noise. Nia's breath caught in her throat, that familiar electric thrill racing down her spine. The numbers told a story, a mass, unseen, tugging at its star with an invisible hand. The room stilled, the hum of machinery fading beneath the silent roar of possibility. Could this be it? Another world, circling a sun not our own? To appreciate the magnitude of this moment, one must understand the landscape through which these explorers moved. For centuries, the night sky had been a domain of myth and wonder, its pinpricks of light the playground of gods and monsters. Even as Galileo lifted his telescope to the moon and revealed its craters, the notion of planets beyond our solar system belonged to the realm of speculation. The first confirmed detection of an exoplanet, orbiting a main sequence star, 51 Pegasi b, announced by Michel Mayor and Didier Queloz in 1995, had shattered that wall of doubt. Since then, the catalog had swelled, each new entry a victory snatched from the jaws of cosmic indifference. Yet each planet is not merely a point on a map. It is a story, a question mark, a mirror held up to the universe that asks, what else is possible? With each detection, the boundaries of the conceivable have been redrawn, expanding the frontiers of imagination and science alike. The discovery of a new planet is not simply an addition to a growing list. It is a moment of genesis, a first chapter written in starlight. Returning to that night at Mauna, the team's exhilaration was tempered by skepticism. The scientific method is an exercise in humility before nature's complexity. Every anomaly must be interrogated, every possibility weighed. Could this signal be an artifact, a quirk of instrumentation or data reduction? The observatory's archives were scoured for corroborating evidence, cross-referenced with data from the transiting Exoplanet Survey satellite, TESS, which had been scouring the sky for planetary transit since its launch in 2018. There, too, the signal shimmered, an ephemeral dimming of starlight as something massive crossed the face of HD 21749, blocking a fraction of its radiance in a regular rhythm. The signature was clear. The planet, designated HD 21749c, emerged from the numbers. A rocky world, smaller than Neptune, with an orbital period of 36 days. Here was a place where the laws of physics played out on an unfamiliar stage, its landscape still cloaked in mathematical abstraction, its atmosphere, if it had one, awaiting the probing gaze of future telescopes. Yet the discovery of HD 21749c, as with so many before it, was not merely a triumph of observation, but of perseverance. The methods used to find such worlds are the result of centuries of refinement and innovation. The radial velocity technique, which detects the gravitational tug of a planet on its star, requires measurements of breathtaking precision, shifts in spectral lines on the order of meters per second, a feat akin to detecting the sway of a galleon by watching the ripple of its anchor chain from miles away. Even more challenging is the transit method, which relies on the fortuity of planetary alignment. TESS, like its predecessor Kepler, watches for the minute reduction in starlight as a planet passes in front of its sun. The resulting dip is often less than 1%, so slight that the noise of cosmic rays, detector imperfections, and even the heartbeat of the observatory itself must be accounted for and subtracted. It is a testament to human ingenuity that, from such slender threads, entire worlds are woven. As news of the finding began to circulate among the astronomical community, the implications unfolded in ever-widening circles. Each new exoplanet compels a re-examination of old assumptions: the diversity of planetary systems, the hot Jupiters hugging their stars, the super-Earths with crushing gravities, the water worlds and gas dwarfs, defies the neat categories that had once defined planetary science. The solar system, it turns out, is but one example among myriad possibilities. But beyond the technical triumphs and theoretical debates lies a deeper, more personal resonance. What does it mean to discover a planet? For the scientists who labor in the shadow of the unknown, it is a moment of communion with the cosmos, a fleeting sense that the universe is not indifferent, that it can be known, however incompletely. For the rest of us, it is an invitation to wonder, to imagine the landscapes of these distant worlds, to dream of skies painted by unfamiliar suns, to ask, as the poet John Keats once did, "When I have fears that I may cease to be, before my pen has gleaned my teeming brain." The story of HD 21749c is, in some ways, the story of all planetary discovery, a story that stretches back through the annals of astronomy to the ancient Babylonians, who charted the wanderings of the planets across the ecliptic, and forward to the engineers and visionaries who will one day send robotic emissaries to these distant shores. It is a tale of patient observation, of false starts and dead ends, of moments when the data refuse to yield their secrets and the night seems endless. Yet it is also a story of community, a tapestry of collaboration that spans continents and generations. The discovery of a new planet is never the work of a single individual, no matter how talented or determined. It is the culmination of countless hours spent calibrating instruments, writing code, poring over spreadsheets, and debating the finer points of statistical significance. It is the product of shared ambition and mutual respect, a reminder that in science, as in life, it is only by standing on the shoulders of giants that we glimpse the horizon of the possible. The ripple effects of each discovery extend far beyond the ivory towers of academia. The detection of exoplanets has transformed our understanding of planetary formation, challenging the so-called nebular hypothesis that had long served as the default model. It has raised new questions about the prevalence of life, the uniqueness of Earth, and the fate of our own species in a universe that now seems crowded with possibility. Consider the work of Sarah Seeger, whose pioneering efforts in exoplanet atmospheres have opened new frontiers in the search for biosignatures, chemical fingerprints that might betray the presence of life, or the contributions of Natalie Batalha, whose stewardship of the Kepler mission led to the identification of thousands of candidate worlds. These are not merely names, but chapters in the unfolding epic of discovery, each building upon the last, each pushing the boundaries of what can be known. The discovery of HD 21749c, like those before it, also raises profound philosophical questions. What does it mean to be alone, or not alone, in the cosmos? The so-called rare Earth hypothesis, proposed by Peter Ward and Donald Brownlee, argues that the emergence of complex life is a fluke, a consequence of an improbable confluence of factors unlikely to be repeated elsewhere. Yet the sheer abundance of planets now catalogued by missions like Kepler, TESS, and the European Space Agency's CHEOPS launched in 2019 suggests otherwise. The so-called cosmic Copernican principle, the notion that Earth is not exceptional, gains strength with every new detection, and yet the data remain tantalizingly incomplete. The atmospheres of these worlds are, for the most part, unresolved, their surfaces mere abstractions, their histories mysteries wrapped in equations. The James Webb Space Telescope, launched in December 2021, promises to change this, its infrared gaze capable of dissecting the light of distant planets and searching for the spectral signatures of water, oxygen, methane, and other molecules that might hint at habitability. But even as technology advances, the act of discovery retains an irreducible human element. There is a romance in the pursuit, a sense of standing at the edge of the known world, peering into the abyss, and returning with a fragment of the truth. It is a pursuit marked by awe and humility, by the recognition that, for all our cleverness and ambition, we are but newcomers in a universe whose scale defies comprehension. In the days and weeks that followed the initial detection, the team at Mauna worked tirelessly to confirm their findings. Independent verification is the gold standard in science, a safeguard against the all-too-human temptation to see patterns where none exist. Observatories in Chile and Spain joined the effort, their instruments trained on HD 21749, their data relayed across oceans and continents for analysis. The process was meticulous, exacting. Each potential source of error was considered, each assumption tested. The radial velocity measurements were scrutinized for signs of stellar activity, flares, spots, and pulsations that could mimic the signal of a planet. The transit data were modeled and remodeled, the signal-to-noise ratio calculated and recalibrated. Only when every alternative had been exhausted, every caveat addressed, did the team allow themselves to believe. The announcement, when it came, was understated. A brief notice in an academic journal, accompanied by a preprint uploaded to Archive. Yet within the community, the news traveled swiftly, a ripple of excitement spreading through the networks of astronomers, planetary scientists, and enthusiasts. Another world had been found, another thread added to the tapestry of the cosmos. The public reaction, as always, was mixed. For some, the discovery of yet another exoplanet seemed almost routine, a footnote in the relentless march of progress. For others, it was a moment of wonder, a reminder that in an age of cynicism and distraction, the universe still holds secrets worth pursuing. The media seized upon the story, highlighting the potential for habitability, the chance, however remote, that life might exist on this distant shore. Yet for Nia Sangare and her colleagues, the discovery was both an ending and a beginning. The planet itself, cold and distant, would never know the thrill of its own unveiling. It would continue its silent revolution around its star, indifferent to the hopes and dreams of those who had glimpsed its shadow. But for the scientists, the work had only just begun. The next phase was characterization, a painstaking effort to determine the planet's radius, mass, density, and atmospheric composition. Was it a rocky super-Earth, with a thin veneer of gas and a surface battered by cosmic rays? Or a mini-Neptune, shrouded in thick clouds of hydrogen and helium, its surface lost beneath crushing pressures? The data, as always, offered hints but no certainties. To answer these questions, the team turned to spectroscopic observations, using the Hubble Space Telescope and ground-based arrays, like the Very Large Telescope in Chile. By analyzing the way starlight filtered through the planet's atmosphere during transit, they could search for the signatures of water vapor, methane, carbon dioxide, and other molecules. The work was complex, the signals faint, but the potential rewards were immense. Characterization is the bridge between detection and understanding. It is one thing to know that a planet exists. It is another to grasp the nature of its climate, its geology, its potential for life. The field is young, its methods still evolving. Yet with each new observation, the veil is drawn back a little further. The story of HD 21749c, then, is not merely a tale of discovery, but of transformation. It is the story of how a speck of data, plucked from the noise of the cosmos, becomes a world, an object of study, of speculation, of wonder. It is a reminder that every planet, however distant, is a mirror in which we glimpse our own origins, our own future. This process of discovery is echoed across the globe, in observatories great and small. At the European Southern Observatory's La Silla facility, astronomers using the HARPS spectrograph have identified hundreds of exoplanets, including the remarkable Proxima Centauri b, a world orbiting the nearest star to our own. At the Apache Point Observatory in New Mexico, researchers with the Sloan Digital Sky Survey have mapped the distribution of stars and planets across the Milky Way, revealing patterns that challenge existing models of planetary formation. Each of these discoveries builds upon the last, forming a mosaic of knowledge that is both beautiful and incomplete. The detection of HD 21749c, like that of 51 Pegasi b, or Kepler 186f, or TRAPPIST-1e, is a node in this vast network, a point of light in the darkness, a step on the long road to understanding. Yet for all the progress that has been made, the challenges remain formidable. The distances involved are vast, the signals faint, the uncertainties manifold. The search for habitable worlds is, in many ways, a search for ourselves, a quest to understand what it means to be alive in a universe that is, by all appearances, indifferent to our existence. The philosophical implications of planetary discovery are as profound as the scientific ones. The so-called Fermi paradox, the question of why, given the vastness of the cosmos and the apparent abundance of planets, we have yet to detect signs of intelligent life, looms over the field. Are we alone, a solitary spark in the darkness? Or is life common, scattered across the galaxy like seeds on the wind, waiting to be found? These questions resist easy answers. The tools at our disposal are powerful but limited. The universe is vast beyond reckoning. Yet the act of searching, of reaching beyond the known, is itself an affirmation of hope. It is a testament to the resilience of the human spirit, to our capacity for wonder and curiosity. The discovery of HD 21749c is, in this sense, a microcosm of the scientific enterprise. It is an act of faith in the intelligibility of the world, a belief that by looking carefully, by asking the right questions, we can make sense of the chaos. It is a celebration of the power of reason, of the capacity to extract order from noise, meaning from randomness, but it is also a reminder of our limitations. For all our cleverness, we remain bound by the constraints of our instruments, our models, our imaginations. The universe is not obliged to yield its secrets. It does so, if at all, on its own terms. And yet we persist. In the years since the discovery of HD 21749c, the field of exoplanet science has continued to advance at a breathtaking pace. The launch of the James Webb Space Telescope has opened new vistas, its infrared eyes peering deeper into the cosmos than ever before. The Plato mission, set to launch in the late 2020s, promises to identify thousands more planets, each a story waiting to be told. The search for life, so long the province of speculation, has become an empirical endeavor. With each new detection, the odds tilt ever so slightly in favor of the possible. The discovery of phosphine in the atmosphere of Venus, announced in 2020 by a team led by Jane Greaves, reignited debate about the potential for life in unexpected places. The identification of biosignature gases in exoplanet atmospheres remains a distant goal, but one that draws nearer with each passing year. Yet even as we peer outward, the discovery of new planets forces us to look inward, to reflect on our own place in the cosmos. The so-called overview effect, described by astronauts who have gazed upon the Earth from space, is a shift in perspective, a recognition of the fragility and unity of our world. The discovery of other planets, by contrast, is a kind of cosmic pluralism, a reminder that the universe is not arranged for our benefit, that we are but one thread in a tapestry of staggering complexity. The story of HD 21749c, then, is not merely a chapter in the annals of astronomy. It is a touchstone, a point of contact between the known and the unknown, the finite and the infinite. It is a reminder that discovery is always, in some sense, a dialogue between the observer and the observed, between the seeker and the sought. The tale of that quiet night at Mauna is echoed in countless other stories, of graduate students hunched over computer screens, of engineers coaxing new capabilities from aging instruments, of theorists dreaming up models to explain the unexpected. The discovery of a new planet is the culmination of 1,000 small miracles, the alignment of schedules and funding, the persistence in the face of setbacks, the willingness to question and to doubt. It is also, in some sense, an act of love, a love for the world, for knowledge, for the sheer joy of discovery. It is the recognition that, for all our flaws and failures, we are capable of greatness, that we can, by dint of effort and imagination, glimpse the workings of a universe that is at once indifferent and sublime. As the days turned into weeks, and the initial excitement faded into the steady rhythm of analysis and publication, the team at Mauna found themselves drawn into new questions. What other planets might orbit HD 21749? What stories might they tell? The detection of a single world is rarely the end of the story. More often, it is the beginning of a new chapter. The search for additional companions is a delicate business, requiring the patience of a chess master and the intuition of a poet. The gravitational interactions between planets can produce subtle variations in their orbits, transit timing variations, radial velocity shifts, and other phenomena that can betray the presence of unseen worlds. The data are sifted and resifted, models constructed and discarded, each new hypothesis tested against the stubborn reality of observation. Sometimes the search yields fruit. In the case of HD 21749, a second planet, HD 21749b, had already been detected, a gaseous world with a mass 3 times that of Earth and an orbital period of 36 days. The system, it seemed, was more complex than anyone had imagined, a miniature solar system, its dynamics governed by the interplay of gravity and chance. The discovery of multiple planets around a single star is more than a curiosity. It is a window into the processes that shape planetary systems. Theories of accretion, migration, and resonance are tested and refined, their predictions compared against the hard data of observation. The architecture of each system is a fingerprint, a record of its birth and evolution. The study of exoplanetary systems has also revealed the limitations of our own solar system. As a model, the so-called hot Jupiters, gas giants orbiting perilously close to their stars, were once thought impossible, their existence dismissed by theorists as an artifact of observational bias. Yet the data were unambiguous. Such worlds are not only possible, but common. The lesson is clear. The universe is under no obligation to conform to our expectations. The diversity of planetary systems is a source of both wonder and humility. There are planets that orbit 2 stars, like the fictional Tatooine of Star Wars, planets with eccentric orbits that carry them from the frozen reaches of space to the furnace of their suns, planets with atmospheres of ammonia, methane, or sulfuric acid, planets that are little more than shattered remnants, the casualties of cosmic violence. Each new discovery challenges the boundaries of what we thought possible. The detection of free-floating planets, worlds that wander the galaxy unbound to any star, has forced a reconsideration of planetary formation. The identification of rogue planets, detected through gravitational microlensing by teams such as those led by Takahiro Sumi at Osaka University, suggests that the galaxy may be teeming with orphan worlds, each a potential site for life. The search for habitability is, in many ways, the holy grail of exoplanet science. The so-called habitable zone, the region around a star where liquid water can exist on a planet's surface, has become a focus of intense study. Yet the concept is more complicated than it appears. The boundaries of the habitable zone depend on myriad factors: the composition of the planet's atmosphere, the presence of greenhouse gases, the reflectivity of its surface. The discovery of planets in the habitable zones of their stars, such as Kepler 186f, located 500 light-years from Earth, has raised tantalizing possibilities. Yet habitability is not the same as inhabited. The search for life requires not only the detection of water and warmth, but the identification of biosignatures, chemical markers that betray the presence of biology. This is the frontier of planetary science, a realm where observation and imagination intertwine. The detection of oxygen, methane, or other gases in an exoplanet's atmosphere would be a game-changer, a hint that life might exist elsewhere. The tools for such detection are only now coming online, their capabilities limited by distance, noise, and the complexity of planetary atmospheres. Yet the dream persists. The discovery of a new planet is not merely a scientific achievement. It is a reaffirmation of the human capacity for wonder. It is a reminder that for all our troubles and divisions, we are united by a common curiosity, a desire to know what lies beyond the horizon. The story of HD 21749c is, in the end, a story about stories, about the narratives we construct to make sense of the world, about the questions we ask and the answers we seek. It is a story about the power of persistence, the necessity of doubt, the beauty of the unknown. It is also a story about hope. The act of searching for new planets is an act of faith, a belief that the universe is intelligible, that the effort of inquiry is worthwhile, that the answers we seek are out there, waiting to be found. In the quiet of the observatory, long after the initial excitement has faded, the work continues. The data are analyzed, the models refined, the questions sharpened. Each new observation is a step on a journey that has no end, a journey fueled by curiosity and guided by wonder. The discovery of a new planet may seem to some a small thing, a footnote in the annals of science, a curiosity soon forgotten. But for those who have devoted their lives to the pursuit of knowledge, it is a moment of transcendence, a glimpse of the infinite, a reminder that the universe is far stranger and more beautiful than we can imagine. It is a moment that belongs not only to the scientists who made it possible, but to all of us, to anyone who has ever looked up at the night sky and wondered what lies beyond. The story of HD 21749c is not the end, but the beginning. It is an invitation to dream, to explore, to imagine worlds beyond our own. It is a reminder that the universe is a work in progress, its story still being written, its secrets still waiting to be revealed. And so we look up and we wonder. We build our instruments, we hone our methods, we ask our questions, we listen for the faintest whispers, the subtlest signals, the hints of worlds yet unseen. For in the end, the search for new planets is the search for ourselves, a search for meaning, for connection, for understanding in a cosmos that is at once indifferent and sublime. We are, as Carl Sagan once said, star stuff contemplating the stars. Our discoveries are not merely data points, but waypoints on a journey that began when the first human looked up at the night sky and asked, "Are we alone?" The answer, if it comes, will not be found in a single night or a single discovery. It will be the product of generations, of patience, of perseverance, of wonder. It will be written not only in the language of science, but in the poetry of the human spirit. And so the story continues. Each new planet a chapter, each discovery a promise, each question an act of hope. For in the end, it is not merely the universe that is expanding, but our capacity to understand it, to see not only what is, but what might be, to dream not only of worlds beyond our own, but of the infinite possibilities that lie within each of us. And as we trace the orbits of distant planets, as we decipher the faint signals from across the void, we are reminded that the greatest discovery is not a new world, but a new way of seeing, a recognition that in the vastness of the cosmos, we are both insignificant and essential, both fragile and resilient, both alone and perhaps never truly alone. The day we discovered a new planet was not just a day of scientific triumph. It was a day when the universe spoke, and for a moment we listened and understood and were changed forever.